going to start working on unit conversions. So we're going to use ratio reasoning and double number lines to convert measurement units. We're also going to do the scaling up, scaling down analysis to figure out how would I actually convert between units. So it'll give us a kind of a quick idea of should the number I'm getting be bigger or smaller. Homework tonight, 2 Matthew workspaces, converting within systems and converting between systems. So we'll talk about the different systems in our lesson today. We're basically talking about the U.S. customary, which is used by all of 3 countries in the entire world. And we'll talk about metric, which is what all the smarter people use. So let's go ahead and open up in our books too. Oh, fire drill coming in. Okay, we're on page 301 in our modules. We're using ratio reasoning with double number lines and ratio tables, convert measurement units. And we're going to be scaling up, scaling down, and unit analysis to convert and transform measurement units approximately. So this is kind of a getting ready lesson for what we're going to be doing with actually doing our conversions. Just to figure out where you guys are at, we want you to do this common measurement conversion really quickly. Literally, we're going to give you 1 minute. Fill out all 5 of these. Fill out the ones you know. If you don't know them, we'll fill them in just a minute. We're on page 301, Brock. Okay, our common ones. 1 foot is 12 inches. 1 yard is 3 feet. 1 kilogram is 1,000 grams. A meter is 100 centimeters. And 1 gallon is 4 quarts. Now, just really quickly, since we got these up here, here is the biggest single difference between the metric system and the U.S. customary. In the metric system, our conversions are easy. Everything is based on powers of 10. And as we've learned multiple times, if I'm working with powers of 10, all I'm doing is moving my decimal. U.S. customary gets really nasty because every unit of measure has its own accompanying pieces that go with it, and they aren't related at all. So once the U.S. and Liberia and Burma, the only 3 countries in the world that still use U.S. customary units, get on board with the rest of the world, our lives will be far easier. Because, little known side fact, in German schools, they hardly touch fractions. You know why? They don't need them. Because in metric system, all you're doing is moving decimals. But because of our U.S. customary measurements, almost all of our stuff works with fractions. So we have an entire number system that we do a lot more work with than most of the world does, fractions, because of the way we measure things. So today is your chance to start understanding these relationships. Now, when we do our different things that we're doing, different things we're measuring, the units we use are different. So we've learned about the relationships between inches and feet, feet and yards, quarts and gallons, meters and millimeters, to name a few. Hopefully you know most of the rest. What we want you to now think about is what customary system unit and metric system unit are appropriate given the size that we're measuring for each quantity. So what we're going to ask you to do is go through this chart, write down both the U.S. customary and the metric system for what units you would use to measure these different things. So I'll give you an example. If I'm talking about height, how do we measure our height in the customary system? Feet, okay? How do you measure it in the metric system? Meters, okay? They will normally use meters and centimeters. We normally use feet and inches, but they normally will talk about how many meters you are. Sometimes they'll just do centimeters, but most commonly they'll use meters as well, okay? So you're going to fill out the chart with what type of measure you're going to use to measure each of these things. So I'll give you guys like 2 minutes. Go, you can work as a table. Okay, I'm measuring my pencil. What's going to be the best unit for US? Jaden?
Inches.
Inches. What about for metric? Centimeters. If I'm doing the school to beach distance, miles. What unit are we using metric? Kilometers. What about the weight of your math book? Pounds, probably ounces, because I doubt that it's more, but I would take either one. What about in metric? probably grams. If you put kilograms, I would take that, but normally you're going to measure something that's smaller like that in grams. Amount of water in a bottle.
Gallons/quarts.
What's the U.S.?
Liters. 2 ounces. 1/4 cup.
Quarts is normally what you would measure. I would take fluid ounces. Cups, not really. We don't normally measure a bottle in cups. What about in metric system? Liters. Okay? So just so you know, in metric, if you're doing liters, it's a capital L. If you're doing stuff like milliliters, you use a cursive L with it. So you can either use a cursive L or a big L. Amount of water in a pool. Gallons. What about in metric? Probably going to go bigger than that because pool's got a lot. Probably kiloliters. Might be liters, so I could take either one on that one pretty easily. Okay? Our second part. Now we're going to use that and think about the most appropriate measurement for each item. Okay, so I've given you 4 options for each of these. We want you to think about, if I'm measuring this, which one of these measurements would make the most sense. So you only have 4 of them. All you're going to do is circle the one that makes the most sense. We'll give you guys like a minute on this one as well. This one will go quick. Guys, please be quiet. So if I'm looking at the weight of a dog, which one do you think would work best? 15 pounds, good. How about amount of gas in a tank?
55 liters.
55 liters would be about the best. 12 kiloliters, that's like a tanker truck, guys. That's 12,000 liters. Yes. I'm sorry? For the height of the classroom? What did you say? 12 feet, yes. And the height of a basketball hoop?
3 meters.
3 meters, good. Okay? So, the whole point of that activity, guys, is, please listen. The whole point of that activity is, realize what you're measuring changes the measurement units that you use. So you need to use the appropriate units when you are measuring something. Okay? So some of these make no sense at all. A ton for a dog? Oh my goodness, I hope not. That's certainly not going on my lap. Right? Okay? Using a kilometer for a basketball hoop? I mean, that's like further than the distance from here to the high school. I don't think any of us are going to make that shot. So you have to think about what it is you're measuring. That's going to help us determine what we're measuring it with. Okay, so on this one, you can use more than one measurement to describe the same length, weight, or capacity. For example, the football field across the street here. You can say that's about 100 yards or 300 feet long. That's the same thing, right? You could also say it's about 90 meters long. In each case, the lengths are the same. You just say them in different ways. So that's all we're saying is you're doing the same thing, but we're using different measurements, which means different numbers go with them. So here's where we need our highlighters. So please break out your highlighters / marking pens. Okay? When we talk about converting measurements, guys, to convert a measurement means to change it to an equivalent measurement in different units. We'll also do on the take note here. When you convert a measurement to different unit, the size of the object does not change. Only the units and the number of those units change. So we're not changing the object that's being measured. It actually doesn't change in any way. It may sound different because we're using different numbers and different units to describe it. So I'll give you guys a second to get that one marked up. Now, let's name a situation in which you need to convert from one measurement to another. Can anybody think of some? Where do we do some natural conversions? What do you think?
Trying to get from one mountain to another.
Okay, but in mountains, anybody know how we measure mountains and heights? We actually use meters, believe it or not. So to measure a mountains we could go, so mountain height, or just really height in general, we would either use feet or meters. Which is actually how we would measure people too. Kind of odd that when we do something like mountains, we still use those measurements. Now, what if we're doing a distance? So like the distance from here to Nago. Miles or? Okay, so distance would be, a long distance would be miles or kilometers. Here's one that Ms. McShann wanted to make sure we added. If I go to the doctor, and I go to an American doctor, how is he going to measure my weight? Pounds. What if I go to a Japanese doctor? How are they going to measure it? In what? Kilograms. Okay? So which one am I going to be happier about when I hear my weight in pounds or kilograms? Kilograms, because it's going to sound like it's less, even though it's the same. Being told I'm 100 kilos instead of 220 pounds sounds better, right?
No.
Oh yeah, it sounds way better. I'd much prefer to be 100 than 220.
I mean, it's twice that.
No, it's the same thing. My weight didn't change. Okay, can you guys think of any other ones? Legend? Okay, so tsunami warnings, and how do they normally measure those? Meters or? No, they'd actually also measured in feet. Feet or meters. Okay, so this gives you some ideas. There's another big one. Whenever we're cooking, we're also going to go tablespoons to teaspoons, or we can also do cups, pints, or quarts. As we increase how many people we're feeding, those are really common conversions. And honestly, guys, this one right here is the biggest reason we need fractions. Yes?
What is the PT?
Pints. Okay, before we start converting units, it's useful to estimate the number of units to expect in a conversion. Here are a few estimates comparing U.S. customary and metrics. 1 yard is slightly, and this is actually a typo, is slightly shorter than 1 meter. So a yard is 36 inches, a meter is about 39 inches. 1 inch is about 2.5 centimeters. That's actually pretty accurate. A kilometer is a little more than half of a mile. So we're doing easy conversions, do it just dividing by 2 works well, or multiplying by 2 if I'm going kilometers to miles. But we need to make sure if you're doing an accurate one, it's actually 6/10. Actually, it's 62 hundredths. 1 foot is about 30 centimeters. A liter is a little more than a quart. And a kilogram is a little more than 2 pounds, but 2 gives you a very easy conversion to use. So our first exercise, we're going to use these estimates to do just a quick change between metric and U.S. customary units. So you're going to refer back to this page as we now go to page 304. So be ready to flip back. So we're going to use the estimates given and the knowledge of U.S. customary to answer each question. Which measurement has a greater numeric value? So there's our big piece. In other words, when I do the measurement, which number is going to be bigger? So our example, the length of a table, is the number going to be bigger if I measure it in inches or in feet? Inches. So all I'm going to do is circle inches. Make sense? So each one of these questions is going to give you 2 options. You choose the one of the 2 that's going to give you a bigger number. Come on down, then you'll answer number 3. How did you decide which one to use? And then you're going to estimate. This is where you're going to use the numbers from the previous page, okay? So you're going to do this entire page We'll give you guys about 7 minutes to do this page. You may work together as a table. Go. So most of the confusion seems to come from the fact you guys didn't pay attention to the question. What am I supposed to be doing? Circling the one that's going to have a bigger number with it. Okay? So, which is going to give a bigger number, meters or centimeters? Centimeters. Which is going to give a bigger number, meters or yards? Yards. Which one's going to give a bigger number, miles or kilometers? Kilometers. The previous page, it said for each kilometer, it's about a half of a mile. Meaning for every 2 kilometers, I get 1 mile. So I'm going to have more kilometers than miles. The weight of your math book in kilograms or pounds? Pounds. Okay? So how did you decide which value was greater? Basically, we looked at the chart showed which was smaller. So the smaller unit is going to have more of them in the same distance, or in the same measure. I shouldn't just say distance because we do all different kinds of measurements. Okay, our next one. Now we're going to estimate each measurement conversion. So the distance is 500 kilometers, about how many miles? So there's our question. So I'm going kilometers to miles. Is it going to get bigger or smaller?
Bigger.
It's going to get smaller because there are 2 kilometers for every mile, right?
Yes.
So I'm going to take 548 and I'm going to divide by 2 using the rough estimate. So that's going to go 2, 14 is a 7, 8 is a 4. So about 274 miles. Because this is an estimate, I would literally take anything from about 250 all the way up to 300. But using the numbers they gave us on the previous page, all I'm going to do is divide by 2 because it's about 2 kilometers per mile. You order 5 kilograms of food pellets for your guinea pig. About how many pounds are you ordering? So there's our question. About how many pounds? So which is bigger, kilograms or pounds? Kilograms. Kilograms. If you look at the previous page, it says it's about 2.2 pounds per kilogram, right? So all I'm going to do is I'm going to take the 5 and I'm going to multiply by 2. Gives me 10. So it's about 10 pounds of food. So of everything we've done on this page, the note I'm about to give you is the most important. Yes? 11 I would take, because 11 would be the accurate if you use 2.2, which is the actual conversion. Okay, this is the most important piece on this page, guys. Please add this note in here. When going from smaller to bigger units, you're going to divide. When going from bigger to smaller units, multiply. Okay? So, for example, if I'm going from inches to feet, I'm going to have to divide the number of inches to find out how many feet it is. If I am going from yards to feet, I'm going to multiply because there are 3 feet in every yard. So a good way to go about this is think about what's happening. The units I'm going to, am I going to end up with more or less? And if you have that in mind, it should make these conversions much easier. Now we are going to show you a way using proportions that takes the guesswork out of it if you'll set them up properly. However, given what we just did with the is of, I'm not so confident all of you are going to be able to do that. So we're trying to give you other avenues to make sure that you get the answers correct. Does anybody need more time to write these down? I'll give you just like 30 more seconds. Don't forget, guys, we always have the video for you to go to later if you miss anything in class. Okay, let's go to our next page. Everyone should be on 305. We need our highlighters again real quick. So I don't know how many of you have ever seen this symbol before, but mathematically, this one means approximately equal, not equal, approximately equal. So it's saying it's about the same as. Okay? So be careful when we're using that's how, that you understand what that symbol means. It is different than the equal to symbol. So because most conversions compare two quantities using multiplicative strategies, you can write conversion estimates using ratio language. You can also write them symbolically in terms of equality. In other words, that's where this comes in. Okay? So they've given us two types. We have ratio language, which is just speaking it. And then you have the actual symbolic equivalencies. So they've given you several of the common ones. And these are the ones that are going to be much more accurate for us to be able to use. Okay? When you use a conversion ratio to convert between units of measure, you often write it as an equation, like this. Okay? You can also take that equation and write it as a ratio in fractional form. In other words, I just take the equal sign and I replace it with a division bar. It's the same thing, but I'll be honest with you guys, this is what we need to get used to writing, because this is how Ms. McShannon and I expect you to be able to do these problems. So we're going to rewrite each common conversion rate using ratio language and as a ratio in fractional form. So in other words, I want you to rewrite it like this in words. So you're going to have to write all the words out. And I want you to write it in fractional form like this. So you're taking the equal sign out. You're writing it as with words, and then you're going to write it as a fraction. Does everybody understand? Okay, just to point it out, part F, this is what we'll call a complex fraction. So you're going to have a fraction over the whole number. When you do fractional form, please pay attention, because you are using the units when I write it in fractional form, which is also very critical for how we're going to teach you to solve these. So we gave you guys a few minutes to practice this. So finish all 6 of these. We'll give you guys about 6 minutes. Go ahead and start. Okay, so guys, this one should have been pretty easy because they gave us the examples right here. Literally all you're doing is taking these words from up here and using the units that they gave you. So our first one, for every 3 feet, there is exactly 1 yard. And then I put it in fractional form. 3 feet over 1 yard. Guys, this is the most important part for you to be able to do, because this is how we're going to be teaching you to actually do the math. So as we start solving these, you need to be able to do that every time with these conversion factors. So our next one, for every 5,280 feet, there is exactly 1 mile. Our fractional form, 5,280 feet over 1 mile. It is also critically important that you write the units when you write this in fractional form, guys. Our next one, for every pound. And here's where the changes, the language changes a little bit. There is approximately, instead of exactly, 4,500ths of a kilogram. And then our ratio, 1 pound over 4,500 kilograms. Our next one, for every 4 quarts, there is exactly 1 gallon. And then our ratio, 4 quarts over 1 gallon. for every mile, or every meter, sorry. There are exactly 100 centimeters. And our ratio, 1 meter over 100 centimeters. Then our last one, for every 1/1000th of a meter, there is exactly 1 millimeter. Now our last part is a complex fraction. So I do the one fraction, making sure everything is together, a large division bar, and then the other unit on the bottom. That's actually more of a 7th grade standard. You guys will get into complex fractions much more next year. But just so you understand, that is acceptable. But we normally try to avoid writing complex fractions. Questions on this page? Okay, next page. Should be pretty simple. When we learned about ratios, we said we can use double number lines to determine equivalent ratios. You can also use double number lines to convert from one unit to another. Many rulers are set up as double number lines. You can use this type of ruler to convert between inches and centimeters. So they've given us an example. All we want you to do, label the scale that represents inches and the one that represents centimeters. How did you decide? And then we've given you 3 questions to use your double number line and answer them based on the equivalencies. So we'll give you guys about 2 minutes to do this page. Do the whole page, go ahead and get started. Okay, the first one, all I had to do is label. So that's centimeters, that's inches. How did I decide? Centimeters are smaller. Guys, stop talking. Okay, use the rulers of double number line to determine. So all I'm doing is going on the this, down for 1 centimeter. Key here, realizing that's 8, so that's about 3/8. If you did 1/2, I would take it. The 1 inch, I just go straight up. That's about 2.5 centimeters, which they gave us. 5 centimeters going on that proportion would be about 2 inches. So that's how that can act as a double number line. If I know the measure on one side, I go directly across the ruler and figure out what it is on the other side. Any questions on that page? Okay, here's the last one. All you need to do, you're baking cookies. You can't find the measuring cups, so you're using tablespoons because you have tablespoons. So all I'm doing is converting from cups to tablespoons. They gave you a double number line. You can watch the video later if you want to. I'll put the answers up, but it should be relatively simple. I know that for every 16 lines, I'm doing 1 cup. So 2 cups of sugar is going to be 32 tablespoons. 1 3/4. So here's half. Half of that again is going to be 3/4. And if I went straight up, that's going to be halfway between 16 and 32 is every 8, 24. So that would be 28. Oh, actually, don't turn it in, Ben.